Hey everyone, thanks for coming. This one's going to be different in two ways. The last seminar or webinar, I was hurried and I went real fast because I had so much stuff I wanted to tell you. This one I'm hoping is not going to be so hurried. The other part that's interesting, or at least different about this seminar is, you know, in the past, I kind of knew a lot about what I was talking about. In this one, I don't, but Chris does. So this is going to be mostly a dialogue between me and Chris Christian, who I'll introduce you to in a minute. And I'm going to ask a lot of questions that I've had. I've been exposed to TAB through, you know, my 25 or so years in the industry. I don't know how long I've been working. And you know, I've always not really understood how TAB works with energy efficiency. And that's what we're going to try to nail today. All right. So what I want to do is start with, I guess, just, you know, we should know who Chris is. Who is this guy we're going to be talking to? Oh, there's his. So this is part of his resume. You don't need to read all this stuff. The main thing is I want you to see what he looks like, so you know, so you can imagine, you know, what he looks like. It's just important to know. He's been around since, well, 1981. This is 2018, so I don't know, that's 30-something years, 38, 37 years. He's been working in HVAC. He started as a service technician, and he's worked doing M&V for JCI, or maybe he was an energy engineer. He'll set me straight if I'm wrong. For us at Abraxas, he does retro commissioning and energy audits, but he's also worked for TAB companies doing TAB, and yeah, I guess that's enough. And he's got a ton of certifications, including one, I believe, for TAB. I think that's the NEBB-CP. And if I'm wrong, well, Chris, tell me, am I wrong? Have I got any of that wrong yet?
No, not yet. Hello, everybody. This is Chris Christian.
Okay. So what I wanted to do is start with the basics, and that would be, I'm going to give you the basics, and it will be my imperfect knowledge of TAB. This is from Wikipedia. I'm not going to read it. Don't you read it. But basically, you know, this is what I usually see when, you know, if you look up TAB, what exactly is TAB? You know, it's testing, adjusting, and balancing. Okay, we got that part. That part makes sense, kind of. So here I underlined a little bit of what I see all the time. So the testing part is they are the TAB people. They're performing measurements of the airflow and water flow. So that's part of it. And then the other part is there's this balancing that they are going to balance the system, and we'll talk a little bit about what that's about, and I guess in a minute. So this is a series of pictures of people doing this testing of airflow. On the left at the top is what they call, well, they're doing airflow testing. They're figuring out the CFM of going through a duct. And what they do is they take measurements every few inches. Chris knows exactly how many inches apart these measurements are supposed to be, but you take all these flow measurements and then you put them in a spreadsheet, and it will tell you this is what the flow is with the CFM through a duct. And the guy on the left, the right, is taking a flow measurement through a diffuser or, you know, a terminal box or something like that. But that's what I know of as TAB, and that's my, you know, my 25 years of experience. That's about it. I know there's a lot of equations involved and all that other stuff, and which frankly does not interest me at all. This is from a TAB report, and it's showing actually the duct readings. You know, so they took what was it, 4 times 8. So they did 32 readings on a duct, and then they end up with a total CFM based on that. So they just type them all in the spreadsheet and it calculates it all up, I guess. But this is what you might see in a TAB report, a lot of sheets like this. This is so what I'm going to show you now are just some different types of TAB reports you might see. This is, gosh, what is it? It's a supply fan, I guess we're looking at, and some, yeah, we don't have to look too closely.
This is actually a rooftop package unit.
Okay, thank you. And I think the main thing that I always notice is they have the design airflow and then the actual airflow. So you know, they find out from the mechanical drawings, you know, what's the airflow supposed to be, and then they go and measure it and see, you know, how far off is it. Let's move on to the next one. This is a VAV box, same thing, but this is the type of reports you might see from the testing. Here's another sheet. This one's really detailed. Some of these tab reports are so detailed. It's so much data. So here I have CFM, the design and the actual, how much outside air, the static pressure. I guess that's it. But they also list, what's the motor and what's the horsepower and all that other stuff. And then this is the last one. I think it might be the last one I'm going to show you. No, there's another one. This one is just showing, they looked at a bunch of different diffusers and they measured the supply air or the flow. I don't know if this might not be diffusers because I see I have supply air, return air, and exhaust air. So let
me explain a little bit about this. This is actually a room report. So you're looking at air changes per hour in this case. This would be like for a hospital or a patient room or something like that, where they're trying to make sure they turn the air over a certain number of times an hour. They also maintain a positive or a negative according to what's in the room. So you get a report like this. These are room numbers, and by room, how much air is going in, how much air is being pulled out, whether
Nice.
you're net negative, net positive. So it's critical for healthcare.
Excellent. Very good. So this is detailed, very detailed work. This last one this one's interesting to me because I've never run across one of these before. So this almost looks like retro commissioning. You can just see a few items, but I'm sure there was a lot of pages in this. But for these different units, they found, if you look at the deficiency issue, these are like retro commissioning type items.
Now this is new construction actually, and this is the deficiency report when we go through the test and balance procedures of what's missing. And so if we keep track of when we found it, when we rechecked it, if it was fixed, if they told us it was fixed, and then we accepted the fix. So some of these issues were still left undone at the time I put the report together. What this is all tracking in the project, this is retro commissioning or new construction, either one. But these are all deficiencies that you find doing the test and balance work.
Good. Thank you, Chris. Okay, I believe this might be my last slide. So what I have here is, I just took this from Wikipedia, and this is actually the root of all of my questions about TAB. And that is, so they do all this testing. That part we can make sense. I can comprehend, and I'm assuming that if I can, then maybe you can. But the part that I stumble on is adjusting. So what they do, and Chris will also make this clear, they're going to, in terms of flows, if it's fluids like chill water or heating hot water or something, they have these balancing valves. I think, is that the right word, Chris? Balancing valves? Yeah. That they will adjust to make sure we get the right flow to the coils, the heating or cooling coils or whatever. So that's what they would adjust. So that's the adjusting part. But for airflow, then they might do things like, change the damper minimum. I think they changed the damper minimum CFM, or maybe what they could change is there are some balancing dampers sometimes inside of the ductwork, which would restrict flow a little bit. That would be adjusting. But the questions that I have, and I guess we'll get to this a little bit later, is adjusting to what? And I won't. Let's not answer that question yet, but that's the thing that's always been a stumbling block for me. So I guess that I'm pretty much done talking. I'm only going to ask questions from here on. Chris, can you add to or enlighten us further on what I missed?
So let's go back to the original premise of what the definitions are. If you say test, ASHRAE defines TAB work as the process of checking and adjusting all the environmental systems in a building to produce design objectives. All right. So to test is to determine the quantitative performance of the equipment. Adjusting is to regulate the specified fluid flow rate and air patterns at the terminal equipment, such as reducing fan speed or increasing it, adjusting a damper, and such as that. So you're trying to trim this system down to get it to perform to a certain level. And then balance is to proportion the flows within the distribution system according to specific design quantities. Now, TAB work breaks down into two categories. There's new construction, where you have a brand new building being built and you're trying to test adjust, and balance to the engineer's design. And so that's a completely different focus. The goal is to get the equipment balanced to the point of the engineer's design as best you can. So you have that piece of paper, all the information from the new construction. Tab for retro commissioning is a different animal. You still use the same procedures. However, you have a different goal in mind. You're trying to be more efficient. You're trying to come up with energy conservation measures. You're trying to verify equipment performance. And so you're right, John, when you say adjust to what, because now you're getting into a different realm. You have an existing building, you're trying to make it work better. And that's the goal. That's the goal for retro commissioning tab work. And that's where really the firms start to divide up. There are a lot of firms who do the new construction work, and that's their focus. They get in, they do the work, they get out, they submit the report, and they're on to the next one. Tab for retro commissioning is a different focus. You've got the same procedures, but you're looking for something specific. You're either looking for efficiency, lack of efficiency, it's fallen off, it used to work, or it never worked. We run into that every now and then. But you're always constantly got your eyes open, looking around, looking for why this system is not working, because obviously you're there for a different reason. The energy is too high, the equipment's not performing like it should, or something else is picking up that has you engaged in the project. So there's a different focus on the retro commissioning side.
So this is where, let's get to what I'm stumbling on. So let's say you're doing tab for retro commissioning, and that's really, I guess that's my focus. And you run across, you do these measurements and you realize, okay, nothing is to design. Now, a lot of tab companies, I think, and tell me if I'm wrong, Chris, but I think a lot of tab companies, they would say, yeah, look, we need to make some adjustments. It doesn't match what the mechanical designer came up with. That's what some of them are going to adjust it to. Is that right?
That's true. If you have a design that you've given them to engage, then anybody who has a certification can do the tab work. The procedures are the same. However, coming up with those values, that's the question. Which values are you going by? Are you going to go all the way back to the original design if nothing has changed in the building? No remodels, no repurposing of the space, you haven't rearranged the furniture or the offices or the walls, then yeah, you go back to the original design if it was energy efficient. Now that is the next question.
Right.
It was the original design efficient? Well, yeah. We assume the design to be efficient. However, one of the things we found out is that after, on paper, it could be fine. But once they install it, you get a different system altogether. The installation you lose some efficiencies between design, installation, and occupation. So there, all along that line, there are losses. We call them losses, but you may not be as efficient as the design. So yeah, if you didn't do anything to this building and it's 20 years later, then yeah, you can go back to the original design, get it recalibrated, reset back to the original, and go from there. But were you happy with that? That's the first question. Are you happy with the original design? If you're not, then we have to go a different direction.
Okay, yeah. So Chris, this is where I want to interrupt. And maybe maybe I'm showing my ignorance again, but I think that a lot of times original design's not very good. And having worked at and seeing people who've designed things, this is, at least in my experience, in every industry, the majority of people who are doing work are doing mediocre work, which is not very good. And so that makes me think that a lot of these designs aren't good. And so why would I want to try to bring this back to mediocrity, which means that a lot of the stuff isn't going to work right?
Right, and so that's where retro commissioning is coming in to say, okay, and I don't want to, I know there may be some engineers out there who may get offended to this, but one of the things is that when you're designing a building in new construction, you're trying to accomplish a goal of an occupied space. Your energy efficiency may not be the first priority. So you want to be able to heat and cool this building with the equipment, with the right size equipment. Then you start looking at efficiencies. You get the most efficient equipment to do the job. Remember also that tab for new construction is going to set the building up for its minimum and maximum performance. Minimum and maximum, nothing in between. Okay, now that means that if I can get the maximum CFM, I'm going to get that. And then I get the minimum CFM. That's it. Retro commissioning comes in and says, okay, we're going to look at everything in between the min and max. We're looking at your most efficient operating point for your equipment. Where is that? And are you accomplishing that? Are you running at that the majority of the time? That's an unknown, because until you start really researching the equipment and how it's installed and how it's operating, then you can apply your tab principles and procedures to determine that, yes, it is working at its most efficient, or most of the time, no, it is not. And so you have the actual proof right there in your hand as far as the testing and all of that. And then you go back to the adjusting and say, how can I get there? How can I get to the most efficient point? Because that's not what the tab firm for new construction is doing. If you go back to the original design, you get back to the original values, you're resetting the building back to the original, but you're not talking about its most efficient operating point. You're just going back to the original design. And so retro commissioning is going to focus on your most efficient operating point. You're right. Now, a lot of firms are not focused on that. It's according to what you look at the focus. You have a lot of firms that do tab only, and that's all they do. They'll do that for new construction. They hire people with minimal skills, but they're not focused on energy efficiency or energy management. They put tab first as their main source of income, whereas a retro commissioning firm puts tab as a tool. That's one of their tools in the box. We're going to use this to get this system back to where we need to get it. And then that's after we've decided where we need to go. So we test to begin with to establish where we're at. We look at where we need to go. We make the changes. We think about it. We calculate. And then we come back with the tab procedures and put it in operation with the new numbers.
Okay, so Chris, here's a question. We go and we're looking at a zone, and maybe it's been repurposed or whatever. They add some walls or took out walls. We notice that we'll say that happened, and we notice that it doesn't, our measurements don't match design. Well, I guess that makes sense. Someone adjusted these at some time. We don't know who. But we also know that people are complaining because they're too hot or too cold, or maybe both. The question then I have is, how do you know how much an adjustment to make? Do you need to be a designer or to do design calcs and all that stuff to make those determinations?
You may not have to be a PE, but you do have to understand the fundamentals. There are rules of thumb. There are assumptions you have to make, and obviously if somebody's not happy, that's why you're there. You have to approach it from a service point of view. So you're there for a reason, and they're not happy with the building, so we got to find out what's wrong. And that's where tab comes in. We come in, we measure, we figure it out that, okay, we're just not getting enough air, or it's not cold enough air, or it's not warm enough air, according to what we're trying to do with the space. And then you start looking at the ductwork. You look at the layout of the floor plan. You look at the capacity of the air handler. You look at the capacity of the central plant. You start looking at, can I get where I need to go? And then you have to figure out where I need to go. Is that at a good place or not? Can we get there? And so there may be some major recommendations like change in ductwork, or we may have to reevaluate how we get the airflow right, or change this to a different size duct. Yes, you do need to know a little bit about mechanical design. If you are out of your depth, you then rely on if you need a stamped design, you go back to an engineer, engage them. But usually you can figure it out just by rules of thumb or best practice. I'll give you an example. We had a hospital that they came up with the energy conservation measure was to change the amount of air they're moving in the building. They figured out they needed so many air changes per hour. So we had to do this entire hospital. That was thousands of rooms. but we had to change the maximum on the settings. So we did this. However, what we didn't do was to go back and verify that we actually were moving that much air. So it was a gamble at that point on whether you actually made a difference or not. You had no way of verification. We didn't go back with test and balance and say, yeah, we're doing what we're supposed to do. Because really that would be expensive. You'd have to go over the entire building. But they had some background to understand that we needed this many air changes per hour in this room in order for it to be more efficient. And that would reduce the total amount of air we were moving for the building, and that would reduce their energy use, but we didn't violate any safety laws or minimum ventilation or anything like that. So we followed the best practices up to a point, all the way to the point where we did not verify the actual airflow after the fact.
Oh boy, so this is a little confusing to me still, unfortunately, and I'm so a lot of companies or a lot of buildings go and have tab done. I mean, is this something that's just, do they just, you know, do this every 10 years or something, or is it, why do they do it besides, oh, there's a lot of people complaining or the system just doesn't work?
Well, and that's the thing that we go back to the original premise. If it's the tab firms for new construction won't do that. They'll do whatever you tell them to do, but they're not going to look for the solution. RCX firms look for the solution. So they're going to use tab to help them find the solution. You may assume that we don't have enough airflow, or you may assume that we aren't just operating at the right point, but you don't know that until you actually do a test. And so they use the tab effort as a test. You can engage a tab firm, but you have to tell them specifically what they need to do. Whereas an RCX firm that does tab also, then they would know exactly what they're looking for. If I'm looking for a problem in a zone, I know what I'm going to look for. And so that cuts down on the guesswork. I'm looking for this much air, this velocity, this temperature. All of these things need to be present in order for me to assume that I can accomplish whatever I'm trying to do and maintain efficiency. That's the other part. Tab firms that just work on new construction are not going to look for efficiency.
Okay, so another thing that had come to me, or at least had occurred to me, is I think tab is really expensive, isn't it? I mean, you saw that one report with the air changes per hour. I mean, imagine how many man hours something that would take for a hospital, or for your example before, you guys didn't go back and measure things because it was probably too expensive.
Right.
You know, we know that, or we don't know, but we've read over and over from all these studies that retro commissioning has a payback at 2 years or less, or so that's what they say. And I choose to believe that. But tab is a different story because it's so labor intensive, and I would think so much more than retro commissioning. That doesn't really have a really good payback, does it?
That's why the effort is reversed. You don't do tab and then retro commission. You retro commission and tab is part of that. You're going to focus your tab effort on specifics. It took me almost 6 days, I would say 6 days of sitting at a desk and reprogramming that system to change the min and max values. And I had to do it. The hospital was in Michigan and I'm in here in Fort Worth. So I had to do it remotely, crossing my fingers that I kept up a good internet connection so I could stay with it. But it took me 6 days. So that was just changing the values. Then you would have to focus and say you can do a random sample or something like that. But if you're trying to come up with a complete system, yeah, it's labor intensive, but you focus on what you're after. You're not doing a full-blown complete retab of the system unless that's what the client wants. If a client wants to know exactly what their building's doing, then you do a full retab of the entire system. And it does take man hours. But it just does. I mean, that's just what it's going to end up doing.
So sometimes when we see these retro commissioning RFPs from the federal government, they want tab as part of it. And are they, I guess this is a real general question and it's always, well, depends, but I'm going to ask it anyway. Are they looking for a complete tab, like showing all those reports, showing every zone and the airflow of every zone? Or do they just want tab to be another tool in the toolbox? And here's a zone that looked kind of funny. We noticed it when we were doing a point-to-point test, so we decided to do some measuring of the airflows too.
It's both, because I do know what you're talking about. Sometimes they want to recategorize the building. And so the tab report will go over every piece of equipment. It'll list every piece of equipment you've got, everything that they read and measure and adjust. They will write it down, and so they'll locate it just in case somebody added something that wasn't on the drawing. We run into that a lot, where somebody has made a modification that they did not document, and so 20 years after the building's built, here's this new piece of equipment that nobody knew anything about. So this is one of those issues that had it's kind of a surprise every now and then for buildings like this, that they didn't really track the changes they made in the building. And so now they're expecting the tab firm to do that for them. So I do see that sometimes. I would, before engaging in a full tab effort though, I would make a preliminary report saying that we need to do test and balance on this system and not the entire building. So for to be more cost effective, you start doing that. I think this system is suspicious. You need to put the effort into this, and the rest of them look okay or not as critical. So retro commissioning is kind of a list by list thing. If they want to redo the entire building, fine. You can engage any tab firm to do that. But again, like I said, their focus may not be energy efficiency.
Okay, and you mentioned at one point, at least I talked to Chris a little bit before this, and one of the things Chris was talking about is there's a difference between good and bad tab companies. Oh, by the way, you guys, we're not going to try to sell you on Abraxas doing your tab, okay? That's not the point of this. So we're not going to, like, you know, say everybody else sucks and you need to work with Abraxas. That's not the point of this. So can you explain what you meant by a good versus bad tab company, or is that, yeah?
Yeah,
With that?
yeah, and I'm going to be as politically correct as possible, but you know, I'm a commissioning agent also, and so I have to deal with tab firms that are not my own, or I might not know them at all. There are a lot of firms that I do know them and I trust them very well. However, there is a track record with certain firms that aren't very good, and I'll give you one example. I was a commissioning agent on a building where I was to verify tab by a random sample, and so I got the tab supervisor out. I know him very well. I don't know the guys that actually did the work. So a random sample, there's only like 16 VAV boxes in the entire building. We pick one, he reads it, nothing's right. Nothing matches the report that I'm looking at. The values are way off. Okay, that's one down. So we keep going. Eventually I told him that, okay, if we get to 6 systems and we're not good, you need to do it all over. And that's what happened. We could not find one out of the 6 that matched their report and the design. So he had to redo the entire building again. And then I have to come back and re-verify.
Does that mean did they make it up, you think? Is that what you're thinking?
Either that, what I think is more along the lines is the technicians who did the work were not well trained. And that's where the real problems begin. I've had to train their technicians on site to do their job. Sometimes I had a hydronics issue where the guy was testing a pump and he said he's got the flow, yet we have flow meters installed that were calibrated that are way off compared to his flow. And I said, well, there's a problem here. And I had to ask him, okay, show me what you're doing. So he showed me what he was doing. I said, okay, here's problem number 1. The system has air in it. And so you're picking up the pressure difference on the pump because there's air in the suction. And so it's artificially dropping the pressure on one side that makes it look like the pump is doing the right flow, whereas it's not pumping anywhere close to the right flow. And so I had to explain to him about that. I said, okay, what the problem is, they haven't filled the system up very well. You need a positive pressure on the suction side of this pump in order to get the right numbers. He was just a young kid, didn't have a lot of experience. I guess the guy he was working for just told him, okay, hook this to this, hook that to that, read the numbers compared to the curve, and you're good. And that's all he did. I've had to do this a number of times as a commissioning agent because I know test and balance. And that's the other thing is if you're trusting the firm, you get a good rapport with them, then you can trust what they do. But if they are working as part of the project, they probably won the bid by low bid. And so they're just there to get in, get the readings, get out, and then turn the report in. That's another difference between new construction and retro commissioning. When I turn the report in for retro commissioning, I've got a summary, an executive summary that explains all the things that we did and all the things we found and how we made changes to this and how that's supposed to improve the system. New construction is just telling you, okay, this is what we did, this is the numbers, pay your bill. You know, there's no focus on improvement on new construction because it's a new building. If you have deficiencies, like you may have seen the list of deficiencies that we were talking about earlier, that was new construction. I expect the contractor to fix those things, call me back so I can come back and check them off the list. But not everybody does that. In fact, I'll give you a nightmare project where I'm the commissioning agent. I get on the project. It was one of the first ones I did for a firm. The project is about to open. They're about to open the doors for the public. And I asked for the tab report so I could review it so before I do the commissioning. I'm looking at the tab report. The tab report clearly states they are 60% on design of the chilled water flow. And I go back to the contractor. I said, did you see this? He said, no, I don't read those. And I said, well, okay, right now the tab firm is telling you 6 months ago that you're 60% of design. When you're about to open this place, and I don't think we're going to be able to cool this building. And sure enough, they weren't. So we did more investigating. I had to break out my own gear. We did the test, and sure enough, they couldn't get the right flow because the piping was too small. They had to go back to the engineer and ask the engineer to fix this. Well, this place is almost finished, and you're asking somebody to repipe the entire system because they're too low. And it was a bad deal. I mean, sure enough, they could not occupy part of the building for a year because of this, while they tried to figure out what the correction was. And so this is where things like that come up. That was a good tab firm, but nobody read the report. The first one was a fair tab firm. They've actually been under investigation a few times because of these practices that they've been put on probation. So that was a bad tab firm. And you know, you just get that. They hire people right out of high school. It's a part-time job. They're paid minimum wage. They don't really understand mechanical systems. Sometimes they used to install residential HVAC and they know about fan. Okay, take this hood, go read these numbers, adjust the dampers, all this stuff. It's a mixed bag. The high-end firms, like I say, there are two types of firms. Those are in it to make money, those who are in it to make a difference. And both of those firms are at risk of going out of business because the ones who just want to make money will go low bid just to keep the people busy, and eventually they'll do a bad job and then they'll run out of work. So they'll go out of business. The ones that want to make a difference put all their effort into giving you all this information, yet they don't make enough money to stay in business. So at some point, you've got to get the balance between the two to have a firm that makes a difference and can make money. And so that's one of the biggest challenges. You hire people at low end, you try to make a big difference with those people, and it's a struggle all the way through.
That's neat. That's neat. Here's a question that occurred to me. Well, let's go back to that one more time, and I hope I'm not boring people by saying the same question over and over again. Balance to or adjust to what? You know, let's assume they have changed the building, or no,
right.
Let's just say they haven't changed the building, but someone changed the damper positions or the minimums, you know, overrode the minimums or whatever.
Right.
And so it doesn't match design, but someone did that for a reason. And you go and you notice, hey, it doesn't match design. What do you do?
As part of typical practice. The tab firm has to sit down, and that's why they have certified professionals that know how to do this. They sit down and they look at the system from one end to the other. They look for possible problems that may cause issues later on, and then they focus on those things. There's again issues that come about from installation, whereas the drawings say this, but we had to do this in the field, and that made a difference to the performance of the equipment. Yes, usually it's called pain management. I'm going to give you another nightmare. Now this is I'm going to be careful because some of these people may be on this call. I was asked to teach a pneumatics course to a building. It's about a 20-story building for a major facilities management firm for their staff. And they still have majority of pneumatic systems. They have some automation. But I was explaining to them how pneumatics work, and then I took a specific, and it turns out I got the right one for their VAV controllers. It was the exact same one that they were using in this building. So I was talking to them about how it works and how you plug in and all these things and how you set it up. And they kind of perked up when I said set it up. After a little bit of investigation, I found out that they were replacing their failed, quote unquote, failed VAV controllers with the same VAV controller. They just unplug and plug in the new one. But they were not making the adjustments and the settings for the new ones. They just pulled them off the shelf, stuck them in the VAV box. Each one of those has to be set up for the minimum and maximum CFM according to the box, because those controls off the shelf don't know where they're going to be installed. They're set up for minimum, maximum, whatever. And so that led to another discussion about how they seem to be using more energy. Slowly but surely, the energy use is creeping up over the last month or year. And also, they seem to be maxing out their air handlers that they can't keep up. And I said, how many of these have you replaced? Oh, 30%, I guess, over the last 2 years. I said, and you've not set any of them up? You didn't get a tab firm to come out and actually read CFM and set the controller up, or you didn't do it yourself? No, we didn't. So basically, they had taken what was a tested and balanced, we can assume, from original, and replaced it with a controller that doesn't know anything and starts running from, could be 1,000 CFM down to 50, according to however the thermostat calls it. And that thing can go all the way from top to bottom and not restrict or limit the amount of flow. And so they're doing it to themselves without knowing that they're actually having an effect, a major effect on the energy use in the building, just because they missed one part, and that was test and balance. They had to set that controller up. So if they got the information right there, it's on the box or it's on the prints, but they just didn't do it. So yes, if you don't know what you're going to set it up to, that's going to make a major impact. This goes back to either design, that you accept the design or not as effective. But if you've had to constantly go in there and make changes to make people happy, maybe the design isn't meeting the criteria you need. That's when you need to rethink your design and come up with a different plan, but at least it would make sense. You just can't go wide open and expect it to do okay to satisfy one person's problems. That's going to have an effect on your energy management. So it has to have some thought put into it. You have to design or come up with a solution that you can put into play that's not going to break the rules about energy management or airflow or heat transfer. And so that's where your professionals come in, and that's what I'm saying. You need somebody who actually knows how this stuff works in order to figure out, okay, this is a good idea, this is a bad idea, this is a good design, we need to change this design. We've got to make some changes to our assumptions in order to make this work properly. And so when you say adjust to what, that's a good question, because that's what you're going to ask the whole time. What are we going to adjust to? Mm-hmm. I'm going to turn the question around. Not adjust to what, I'm going to ask you, what are we going to adjust to? That's a definite, what are we going to do? Not leaving it open-ended. You're going to come up with a value that everybody's going to agree with, and that's what you're going to go with.
Here's a related question or story, I guess. I heard about a hospital where an ESCO had decided, they had told them to turn down their VAV minimums, or the minimum supply fan speed. And I didn't get the whole story. I just got a little bit, but I heard that they slowed it down enough that there was mold was able to get into the ducts and live there, and they had to tear the whole hospital down. Have you heard of anything like that?
Yeah, I mean, we have heard things like that early on in energy management. Of course, somebody told me that the most expensive air you're going to buy is outside air. It's because that's you got to treat it all the time. So everybody's familiar, I guess, with the famous, we decided to reduce all our outside air down to minimums, and the building got sick, and somebody got sick and sued us. And so that's the one I've heard about. I'm not sure about the tear down the whole hospital thing, but that is one of those problems that we run into. And that's the first thing you think about when you're reducing airflow. Am I going to cause a problem? You've got to go through all that process. I'm not here to make more problems. I'm here to improve the situation. Your first priority is to make sure that you don't have a negative impact on the people or whatever's inside the building when you're trying to save energy. So, the old maxim, you can't save any more energy than turning it off. Yet, if you did that to your entire building, you're not going to have a building. So cutting back on outside air, doing things like this, you've constantly got to think, am I hurting the building, or am I helping the building?
Not just outside air, but supply air as well. I mean, stories like this make me think, or, wonder, it's like, how can energy efficiency or people who do it be successful when there's so much complication? It is so complicated. Oh yes, well, I understand you can look at an HVAC diagram, you can calculate everything. That's not hard. But there's all these little things like pressure differences and mold that could grow, or all this other stuff that you change one thing and everything else changes. And it's, even the best person can't foresee all the things that could happen.
But here again, the experience counts. If you know that you shouldn't go below a certain point, that's where we get in these systems like demand control ventilation. Even that has its ups and downs. It's according to how you measure it and where you measure it makes a difference. If you measure it in one single point in the building, that's not going to help you. If you measure it all in the zones, that's going to help you, but that's expensive. So that's where you get the trade-offs. You've got to come up with effective solutions that don't cause problems. That whole thing about reducing airflow to these rooms based on air changes per hour included surgery. So it's like, guys, so let's think about this. They have alarms on those rooms that if they go negative, then you're in bad shape because you're pulling air in out of the hospital into surgery. You don't want that. You need to stay positive. And so the first priority is we must maintain a positive pressure in this room. And the only way to do that is to add outside air. You have to just pay the price to maintain that. But if you just went in there and said, we're going to reduce the airflow in this room, and that's it, then you're making a mistake. You're putting yourself at risk. And that's one of those things. I'm very risk averse. I don't like taking gambles with the firm or with the client or with anybody who the client does business with that might put them in jeopardy. So I'm very conservative in what I do, just to make sure that we're not screwing up, that we're not making a mistake. And you have to watch that.
Well, here's a question. I guess we should wrap up pretty soon. And this one is, I already know the answer, but I'm going to ask it anyway. And that is TAB something that ESCO should look at? Is like, this is another ECM, like transformers. You can always replace transformers because most of them are old. But is that something, or is it, you can't really do that because you have no idea what kind of payback you're going to get, and it might, give you like a 40 or 50 year payback?
No, it's not going to be something like that, because it's according to how bad it is. If you've got a building that is just way off, you're going crazy. Let me give you another example, and this is kind of simplistic, but If you had a space that was never satisfied, but you could never get it right because the system is compensating for it. So you either reduce your airflow because of it, or you increase your airflow because of it. You're using more energy both ways. If you reduce your airflow, that means your system's got to work longer to try to cool a space where you're never going to get that. Okay, so that's going to cost you money. If you increase the airflow, that increases the energy use, but it might save you money on your central plant. But if you increase the airflow past its design, you're going to use more fan energy, you're going to use more plant energy, and you're still not going to maintain comfort in the space. So there's that spot that you're trying to nail down to be most efficient with. The guy I took over for back 20-something years ago said we didn't have any of this back in the 50s and 60s. We just stuck a piece of toilet paper up on a stick, held it in front of the grill. If it fluttered, we knew we had air, and that's all they cared about. So that was the whole thing about, well, we don't need this, do we? Do we really need this? These systems are designed appropriately with the right size duct, and so if I just turn this air handler on, I'm going to get the right airflow, right? Or I don't need to test and balance this VAV system as long as I can read the CFM coming on the box. It's got the right CFM, right? Well, no, nobody really knows, because until somebody actually tests it and says, yes, it is, or no, it wasn't, and now we fixed it, now it is, you don't know. It's like buying a car that you hope would get 30 miles to a gallon. You start driving it, you really don't pay attention until you fill up a few times. You realize, hey, this thing may not be getting 30 miles to the gallon. How would I know? Well, then you start actually tracking your mileage and your gas usage. You're actually doing test and balance when you do stuff like that. And so you're trying to find out where the best spot is to operate, to get the most efficiency. If you don't care, floor it. I mean, just floor it and do whatever you want to do. But I don't know anybody who likes burning money and just wants to do, I guess if you were rich, I guess you could do that. But you want a payback. You bought that car for 30 miles a gallon because you had one that did 10 miles to the gallon. That's right. I want a better, more efficient car. If that's what you've done for your building, and that's what you expect this building to do, and if it's not doing it, you've got to do something about it. Paybacks like this on tab could be almost immediate, or yes, they could take, if I go through a building and I find nothing wrong, then there's no payback in the time I've spent except telling you your building's fine. And I don't like that, because your building's not fine because you engaged me for some reason to look at it. So I need to really find something that's causing your energy use. And I'm not going to waste my time with the tab if I don't think that's what it is. That's why you need somebody with the experience to understand that, hey, it may not be test and balance, it may be something else. And then save your money and put it into that. So on the retro commissioning side, that's where the big question is. You have to do test and balance for new construction because that thing's not going to work unless you do.
Right.
But the retro commissioning is, yeah, we assume that it's okay and you've got a problem that somebody might have created, and we'll fix that problem.
So we got to wrap up. So I was going to ask you, this is a tough question, Chris. Can you try to sum everything up, or not everything, we can't sum everything, but if you could leave everyone who attends with one or two sentences that they can remember, that they can carry with them for the rest of their careers that would be useful to them, what would it be?
Well, I'm going to try to be brief. I know I've been going on for a long time. It is like everything else. It's a risk management effort. You think you've got a problem, you want to get rid of that problem. You've got a risk out there of energy management or cost, and you're trying to reduce that. Test and balance is a risk management effort. Just like commissioning and retro commissioning, you're trying to find out and identify the risk. That's clear. If it's what you don't know versus what you know, and test and balance gives you that knowing. You will know what's going on. And if you made improvements, you'll know that you improved the situation. It's the knowing that counts.
Okay. That's it. Anyone have, Tyler, can you take over?
Yeah, sorry. So Lizette, we did see your question, and then it kind of went off, and we got sidetracked into a great discussion. Lizette Britton, sorry, has a question for Chris and John. What kind of savings quantity could you typically find? Say a percentage of HVAC consumption. What's involved in determining if a tab retrofit ECM is feasible?
So, rule of thumb, about 10%. If you were made a tab effort, just tab alone, and a lot of problems were found, you could get to 10% easily on savings. If that is, and that would be focused on the HVAC side, it would be 10% of the HVAC cost, whatever it's costing you to operate your central plant, air handlers and such that. Right off the bat, you're looking at a minimum of 10% if the system has gone way off. There could be other issues you find, such as blocked coils, dirty coils, low maintenance. I just came off a job where every drive shiv on every motor needs to be replaced, because over time, the building was 20 years old. Over time, they'd worn down to the point that everything started to slow down. But this is DX equipment, so the DX equipment runs either on or off, and the slowing down of the airflow meant that it had to run longer to cool the space because we're not moving the right amount of air. So even though I increase the speed of the fans to use more fan energy, I now decrease the DX cooling requirements to where I don't have to run it as much. But it's deferred maintenance. They need to get in there and replace all those drive shivs. They also, things like that. They have holes in the building that are allowing cool air to blow out. That's a design flaw that they need to fix. Somebody needs to put dampers in there to shut that off. They have one of these exhaust fans running, blowing air out of the building constantly. They can't shut off. We can't find out why they can't shut it off. And so that's something they've got it. They didn't know about it until we went through it. And it's only supposed to be, it's like a smoke evac fan, but it's running constantly. It's only supposed to be there for emergencies. So things like this is what you find in test and balance. They're running a kitchen 24/7. Outside air in, exhaust air out, but it crosses over into conditioned space. They need to put a schedule on that thing and shut it off when nobody's there. There's no reason to run and bring in outside air all that time to try to cool the building that they're having to cool it. So putting a schedule in would stop that, but they didn't know that until test and balance shows up. So it's a varying thing, but just a rule of thumb, 10% of your operating can be reduced just from effective test and balance.
But Chris, you can't, so this is, I'm addressing the question. You can't just, let's say you're working for an ESCO, you can't just, put on every project, we're gonna do tab 2. There's another 10% of HVAC costs we probably will get, or HVAC savings. I don't think you can do that. You need to do some kind of initial assessment, right?
Yes.
Before you make that an ECM. Maybe what you should do as part of your PA, you do a little bit of retro commissioning investigation, not a full retro commissioning, but you look at things.
Well, and that's why I think I said earlier that the typical process is that you test, look at the results of that as part of your RCX. You didn't adjust anything. You just tested to see where do we stand today. And then you make your recommendations, and then you go back and balance, adjust and balance after that. So you're breaking it apart. Whereas new construction, test, adjust, balance, boom, boom, boom. Go. There's no analysis in between. There's an analysis part in RCX that you look at the project, you figure out where the problems are, you test at that point, and then the results of that test kind of tell you, do I need to keep going with it? Do I need to adjust? Do I need to balance?
But a lot of, so retro commissioning scopes really vary from very simple, like a simple audit, all the way to serious retro commissioning where you test everything. And I would think at a PA level, when ESCOs are first looking at a building, they're not doing that IGA type look. They're not going to be doing, you know, traverses and calculating CFMs for all these different ducts. They're not going to do that.
No, but as part of your investigation, you've got to sit down with the client and say, okay, where is your pain? Where do you think it's going? Because they live and breathe that building 24/7. And so that client knows more about the building than you do when you're walking in there for the first time. And if they have an area that they're constantly having issues with, if they just say, I want to reduce I want to reduce energy cost in my building, that's too broad. I mean, you need to start looking at, okay, specifically, where do you think your money's going? Is it the chillers? Is it the air handlers? Is it down to the zone level? Is there a problem with the building envelope? Is it the way you operate? All of these things don't have anything to do with TAB until you get down to the point that you say, I've got a problem with this area specifically. And that's where I need to apply a test and balance effort.
Wait,
Not
so
going to go over
Chris,
the entire building.
let's say they say, oh yeah, this room over here on the 3rd floor, it's always hot. They're always complaining because it's hot. That doesn't mean that there's energy savings potential.
No.
I don't think.
Well, there could be, because if you don't get the right airflow, if you don't have the right air changes in the space, you'll never get to set point. So if you don't have enough air going in there, or you could have too much air going somewhere else, and it's starving them from over here, like the people who are changing the controllers, they're running out of air because they didn't understand that they had to make adjustments when they replaced those components. So they did it to themselves to the point that now they have to do a full tab and retro commission that building to get it back to where it needs to go. But issues like this, out of calibration thermostats, that could be part of the problem. Failed controls on the VAV box. But when you replace it, you have to set it back to a test and balance level from either the original design, or you come up with your own square foot CFM, things like this. But that's small compared to the entire building. So I'm not saying that you have to retab the entire building, but you're going to focus on where you need that effort. So that cuts down your cost for test and balance. You know, you have to be smart and manage your project.
That's all we have, guys. Thank you, Chris and John and everybody for showing up. I know we ran long, and I hope you guys enjoyed it, and we will see you guys in August.
Thanks, everyone.